Welcome to Get Your FRQ On. This question is from the 2007 exam. It's question 3 and it is calculator active. In the question stem, we are provided with a table of values for two functions f and g, along with values for the derivatives of f and the derivative of g. In question part A, we are asked to explain why there must be a value of r between 1 and 3 such that h of r is equal to negative 5. This seems like an intermediate value theorem question. Right? We are given that h of x is f of g of x minus 6. We're also given that f and g are both differentiable functions, and this is important since f and g both being differentiable means that they are both continuous, which implies that h of x, as defined, is also continuous, which is one of the requirements for using the intermediate value theorem. Right? So we calculate h of 1. H of 1 is f of g of 1 minus 6. From the table, g of 1 is 2, so we take f of 2 minus 6 from the table. F of 2 is 9. 9 minus 6 is 3. So h of 1 is equal to 3. H of 3 would be f of g of 3 minus 6. From the table, g of 3 is 4. Then we have f of 4 minus 6 from the table. F of 4 is negative 1. Negative 1 minus 6 is negative 7. Now that we know h of x is continuous and h of 1 is 3 and h of 3 is negative 7, because negative 5 is between 3 and negative 7, we know that there is a value of r somewhere between 1 and 3 such that h of r equals negative 5. That's guaranteed by the intermediate value theorem. H of 3 is negative, h of 1 is positive. Negative 5 is between those two values, and so there must be some value of r because h is continuous and the intermediate value theorem applies. Part B asks us to explain why there must be a value of c between 1 and 3 such that h prime of c is equal to negative 5. All right, since f and g are both differentiable, they're still continuous, and it implies that h of x equals f of g of x minus 6 is also differentiable and continuous. So we know that we can find h prime of c for any c in that interval. All right, so this sounds like a mean value theorem problem. So if I find h of 3 minus h1, or h of 1, and over 3 minus 1, I get negative 5. So based on the mean value theorem, there has to be a value of c somewhere between 1 and 3, where h prime of c takes on this value of negative 5. In part C of the question, we are given a function w of x defined as the integral from 1 to g of x of f of t dt, and then we are asked to find w prime of 3. Given the definition for w of x as the definite integral from 1 to g of x of f of t dt, the derivative of w we can get that by an application of the fundamental theorem of calculus. So w prime of x would be f of the upper bound here, but the upper bound is a function of g of x. But then we also have to multiply by the derivative of this upper bound if it's a function of x. So w of x is f of g of x times g prime of x. Right? All of those values we can get from the table. Right? So w prime of 3 is f of g of 3 times g prime of 3, and then just substituting values in from the table. G of 3 is 4, g prime of 3 is 2. F of 4 is negative 1. Negative 1 times 2 is negative 2. So w prime at 3 is negative 2. And in part D of the question, we are asked to write the equation of the tangent line of g inverse at x equals 2. Now, derivatives of inverse functions don't show up in free response questions very often. It's pretty rare, but you do have to know how to do it. So from the given table, we know that g of 1 is equal to 2, and therefore g inverse of 2 has to equal 1. Remember, in order to write the equation of the tangent line, we need both an x-coordinate and a y-coordinate. Here our x-coordinate is 2, and based on the table, we can conclude that the y-coordinate will be 1. Now we just have to find the slope of the tangent line of g inverse at x equals 2. All right, so by rule, finding the derivative of the inverse of g inverse of x prime at 2, is the reciprocal of g prime at g inverse of 2. Well, g inverse of 2 is 1, so I need the reciprocal of g prime of 1, which based on the table, g prime of 1 is 5, so the reciprocal of that is 1/5. Now I have an x-coordinate, a y-coordinate, and a slope, and so I can write the equation of the tangent line. I prefer to do it in point-slope form when I have that information. It's just easier to write, and I don't have to do anything afterwards. So one equation for the tangent line of g inverse at x equals 2 would just be y minus 1 equals 1/5 of x minus 2.